These are the supplies we had. The stationary phase is the paper that we used. The mobile phase is also called the eluent. That word, you don't really need to know it yet, but it's good if you start remembering it because eventually you will use it. So the mobile phase, that's the solvent. So it was the water for us in this case. And the solute in this case was the dye. Great. Oh, we don't care about the video. So now, one thing that we did not do, this is our lab right here in the back. These are some of the people's results. But we did not measure the distance, although we could have, but we can measure it here. We cannot measure it as a class. This is black ink with ethanol. But all you really need to do is calculate the RF factor. The RF factor is the distance that the solute travels divided by the distance that the solvent travels. So what we're gonna assume in this case, and what we normally assume and what truly really does happen, is that the solvent travels as much as the one that has the highest affinity. So if we wanna measure this here, what would you say would be the reading for this blue-purple looking one? It could be 7. It doesn't, it's like an educated guess. So, or it could be a little bit greater than 7, depending on what you're looking at, but about, right? And we said that the water travels the same distance. So the RF factor, or the retention factor, for the one that travels the most will be, in your case, you said 7, divided by 7, so it'll be 1. So the one that travels the most is always gonna be 1, right? Now, what about this red one? If I said the red one traveled to about there, it's about 6.4. Right? Divided again by 7, if we called the water or the solvent travels 7. So that will be the RF factor for the next one. Does that make sense? And then what about the yellow ink in this case? What would that be? How much? 3.5. So that's what you're calling it, right? Yes. And then the retention factor will be that. The retention factor will be 3.5 divided by 7. And what this says is literally the same thing that we've seen. It's just in numbers to say, hey, this is the one that traveled the most, because it's 1. This is the one that traveled a little less. And it cannot give you a number to have an idea how much less did it travel without seeing the actual paper, right? And then this one is going to be the one farthest away from 1. It's going to be the one that travels the least. So this is the less polar of all of them, right? That's all that is it. I mean, retention factor sounds like something really fancy, but in reality, it's not. And now this is the important part. You may have already done it. You don't have to do it again. But if you haven't done it, just write it. You can write it on the comments, that you submit. It doesn't really matter to me. I wanted you to see how the actual lab turns out. These were actually last year. I thought these were this year, but these were last year. Very similar. And that's it. That's all for the chromatography lab. So I think we understand it. I hope we do.